For the past few days, we've been looking at infinite series, and we have looked at two kind of specific types of infinite series. One was the n-type series, where we had ones like the harmonic series. It's an infinite series. Okay, so that is an n-type series, and those sums, they have a sum. The harmonic series happens to be infinite, so it diverges. And we also looked at last day specifically at something called the power series, which can represent functions, and it has an x in it, so we can distinguish it with these x's. And these represent functions of x. And the power series, 1 plus x squared plus x cubed, happens to be a representation of the function 1 divided by 1 minus x. Now, what's really important is that this idea of convergence. These are only useful to us when they converge. So the harmonic series is a boundary series of divergence. So that one diverges, but we can use that very effectively if we understand that anything that converges quicker to zero is a converging converging series. We also looked at some of these that happen to be put together when we had x's and n's put together. And those are these functions that are mixed, are these f of x, or the power series and the n series knitted together. The examples we looked at last day were things like e to the x, sine x, cos x, log x. These are much more complex series or complex functions that now can be represented with these power series, which are essentially polynomials, which are kind of simpler, more simple functions. And we knitted these together with the Sn series. Those two together can make really complex functions that we can analyze very easily as polynomial functions. Okay, so that's kind of a summary of what we've done so far. We're just going to focus on some key ideas in that we really need these series to converge. Okay, so for a series to be able to represent functions, we need these series to converge, whether they are by themselves as a power series or knitted together with an n series and a power series. These have to converge. And this can happen for all values of x. It can only happen for some limited intervals of x, so limited domain, such as the power series was only good for certain values of x. But what the important part is when they did converge, we can use them to represent these pieces of functions. Okay, so convergence is key. So we're going to talk a little bit about convergence to start. And this is something we have already talked about, this idea that for an infinite series to even have a chance of converging to a finite sum, it is necessary for the term number to go to zero. So an example here would be this an equals root n. Okay, so that term number, n, as n gets bigger, it gets bigger and bigger and bigger. And so if we're going to add up all these terms and every term gets bigger, we're going to have an infinite sum. So this is diverging, and this is not very useful to us. Okay, we need these things to converge for us to be able to use them. So we can just eliminate that right away. Now, the harmonic series does approach zero, so it does pass this first test, and this is really only the first test. This is our first test. And the harmonic series does pass the first test. Okay, the sequence does go to zero, so these terms just get closer and closer to zero. So this at least has a chance of converging. However, we do know that, and we've looked at this already, that the harmonic series does not converge. So this is only the first test. It is a necessary but not sufficient condition for the term numbers to go to zero. Okay, so our very first condition, if an is a non-zero value, we just eliminate it right away. It doesn't converge, we get rid of it. Okay, we don't have to do anything else. If it passes the first test and that an does go to zero, we have further tests to do. It's only the starting point. We can just move. This just gives us an okay to move to the next step. And we're going to have some tests later as our next steps. Okay, but this has to pass our very first condition before we even move on. So although this is a check, it's still a question mark. Okay, it only passed the first test. There's more to do.